All right, we're going to describe a situation that possibly could help you in some of your assignments. And I'll talk about it in general first, and then we'll talk about how maybe it could help you in your assignments. All right, let's say we have a situation of doing a application for a pet store. And a pet, pets can be, and I'm going to keep it simple. So if you have an iguana for a pet and I don't mention them, please bear with me. We have cats and dogs. Parrots. Parakeets. Iguana. And snakes. So let's say this is the pets that a pet store carries. They carry these 6 pets. Now, you might look at these and see that some of these things have things in common. And for example, these are all mammals. So we could create a superclass for mammals and put all the things that dogs and cats have in common in that superclass. Likewise, we could do it for birds. We could do it for reptiles. Then if we think about it some more, we can think, well, there's something that these 3 categories have in common. They're all animals. They're all pets. So I could create a superclass called pets. So I could create superclass for pets, mammals that inherits from that, birds that inherit from that, reptiles that inherit from that. Then cats and dogs inherit from mammals, parrots and parakeets inherit from birds, iguanas and snakes inherit from reptiles. Now, here's the thing. If someone called the pet store and wanted some information about their pet, all right, what kind of food should I feed my pet, for example? Person on the other end of the line, the person that works for the store, will probably say, well, what kind of pet is it? Now, would the person ever say, it's just a pet? It's not a mammal, a bird, or a reptile. It's not a cat, a dog, a parrot, a parakeet, an iguana, or a snake. It's just a pet. That doesn't make sense. No one owns just a pet. Everyone owns one of these. So what about these 2 layers of classes? These 2 layers of classes we can define as being abstract classes. An abstract class is a class that you cannot create an instance of. So I can't say something like pets P equals new pets. That is not legal because this is an abstract class. I can say pets D equals new dog. Why can I do that? Because my pointer will hold any kind of pet, but the specific pet I'm creating is a dog. So I'll get all the dog methods for the different methods that pets can do. So that's the idea of an abstract class. An abstract class allows us to put in attributes and behaviors that subclasses share, but there will never be an instance of the abstract class. That is, no one owns a pet. People own a cat, a dog, a parrot, parakeet, iguana, and snake. Now we can have things such as abstract functions. We could say, one thing we know is that all animals, there's a list of things they can eat and a list of things they can't eat. So maybe I'll have an abstract function in pets called get food list. And that might return an array list. An abstract function only contains the function signature. That is the name of the function, the return value, and the arguments. All right. So let's look at this example. I have, I think, a scaled down one, but I have a pets example. I only have two classes, pets and dogs. So it's very much scaled down. Here's my class for pets. Here's my class for dogs. And here's my unit test. All right. So if we look at this, pet is defined as an abstract class. That means that I cannot create a pet object. I can only create a kind of object that inherits from this, a concrete class, if you will. But still, that pet class can have attributes. For example, all pets, I'm going to assume, have a name and a weight. So whether it's an iguana or a dog, probably has a name and it has weight. And so I create a constructor for that. I could put in here some other functions. And I implied that I would have gets and sets for these attributes. So I would have public set name, public void set name that accepts a string argument and sets the name. I could have a get name. So my abstract class could have some real functions in it that deal with the properties that are defined on it. But it can also have these abstract functions. Now, what does it mean to define something as an abstract function? It means that everything that inherits from this, that itself is not an abstract class, has to implement this function. So I have my dog here, and my dog extends. Oh, I didn't see it for a second. Public dog class dog extends pets. So pets inherits from dog. So I don't have that middle layer of mammal in this example. I just have the dog example. But it extends pets. I have not defined dog as an abstract dog. You know, I could do that if I wanted to have a separate class for each breed of dog. But in this example, we're considering dog enough. And I said that there's a couple attributes that exist for dog. How many weeks do you need its toenails cut? And what kind of hair does the dog have? I have a constructor. I have actually 3 constructors that I chain together. Actually, oh. So if I call and give it the argument of name and weight, it's going to call this classes and give it these 3 arguments, name and weight, and it's going to default the hair to short. And if I call this function, it's going to call the 4 argument constructor that accepts name, weight, kind of hair it has, and default the weeks to 6 weeks to get its haircut. Finally, if I give all 4 arguments, then this gets called. And I have this call the superclasses constructor to set the name and the weight for it. So this should be kind of review. This is just a bigger example of constructor chaining. First line either has to be this or super if I'm going to do it. So this calls a constructor on the object itself. Super calls its superclasses constructor. So you can see no matter what constructor we call, eventually it's going to make it to this one. Now we might default some values. All right. But eventually it's going to call this, and this calls a super, because if we call a constructor on a subclass, the superclass has to be, superclasses constructor has to go first. So I have set hair type, and I would have get hair type. I would have make a sound, get food, catch frisbee, get toenail weeks, get hair type. Now notice I don't need to have get and sets for name because that exists on the superclass. Notice, however, for these abstract classes, because this is not an abstract class, I have to have an actual function here for make sound and get food, which I do. So let's compile this, run it, look at the results, and then we'll try to do some things with this. All right, I'm creating a dog. I'm assigning it to a class of type pet, which I can do because dogs are pets. And I can call get sound or make sound, get food, and get class. I then am going to cast a new variable called D for dog, and I'm going to cast that pet as a dog. What this instruction says is take this variable and make a dog out of it. Now I can do that because I created a dog in that variable. If I had new cat here, for example, if I had a cat class, I couldn't cast it as a dog. So let's save this, compile it, see what we get, and then we'll play around with it a little bit. So I can say Java C star dot Java. And it compiles without errors, and I can run the unit test. Spot says, bow wow, this is what the dog eats. Table scraps, dog food, pretty much whatever they can. Class is dog. When it catches frisbees, it says, yay, yay, I love catching frisbees. Let's go for a ride. And the number of weeks for getting its nails cut is 4. Now, let's see what happens if I get rid of this function. I'm just going to comment it out. No, not this function, my mistake. This function. And I'm going to comment it out here. All right. Try to compile it. I get an error, and the error is a pretty good description of what's wrong. It says that dog is not abstract, and it doesn't override the abstract method get food in pet. Okay, so what that is saying is dog is not an abstract class. We don't see abstract here. All right. It extends pet, and therefore for any abstract functions in pet, dog has to have one of those. So we define it, all pets have these functions. Now the details of the functions are going to be different. The sound that an iguana makes is different than the sound a dog makes, and the food that a cat eats is different than the food a snake eats. So they each are going to have their own function, but they have to have a function for make sound and get food. And if we get rid of that function from here, when we compile it, we get this error. So let's put that back in there. Now we should be back to where we were. Sure enough, we are. Now another thing, let's look at the unit test. What if I say catch frisbee? You might think, well, this is a dog. I can call the catch frisbee function. However, when we look closer to that, we'll see that variable s is declared as a pet. Variable s is declared as a pet. When I say declared as, I mean that's what's on this side of the equal sign. So our pointer can point to a pet. It can point to any pet. However, only pet functions are allowed to be called on that object. So I can't call catch frisbee because catch frisbee is a function that's declared on a dog. Now, if I did this, and say dog S1. One thing I like to do in my output, by the way, is put a blank line so I separate my test cases. Now, because that pointer can hold a dog, I can call all dog functions on S1. So I can call catch frisbee. Or not. What did I do wrong? Oh. Compiles, and the last one, remember I couldn't call it on this one because it was defined as a pet. So I can only call pet functions on this. If I cast it to a dog, then I can call dog functions on the new pointer, because the new pointer I said is pointing to a dog, so I can call any dog function for it. And likewise, if I create the dog, as I do in the last example, I can call that. All right. So abstract classes are a way that you can put classes out there that have functions that we want to guarantee every member that inherits from that class is going to have. So in this case, we have the get food list. If we make this an abstract function and this extends this, which extends this, I could make that abstract and that abstract, but this one I would have to have, in this example, a get food list function. What does that mean? That means we could create an array list, an array list, and we can put in the array list all the pets that we're going to deal with today, all the pet objects that we're going to deal with today. And we could run a loop, and we could call any function that exists on a pet. All right? So we could treat all the pets the same way. All right, and know that every pet, everything that's defined a pet, because that was an abstract function, is going to have get food or get food list. Now, that's when things are all in a given sort of inheritance structure. Sometimes we have something like this. Oh, how I would use this in the assignments? Well, for example, with the magazine one, I might have a subscription class that is abstract, that has, calculate renewal cost, calculate due date, and I could make those functions abstract. Then what I inherited from that for each of my subclasses, basic subscription, student subscription, and premium subscription, I would have to implement those functions, because then, again, remember, I want to be able to put all these in an array list, loop through, and output the results of all the subscriptions, how much that is due, when is the renewal date. So abstract classes work good when you're talking about within a email, not email, that's our next example, within a inheritance structure. At this, make sure I have the example I think I have. Okay. Now, let's say I have an organization like a college. All right. And I may have certain classes like this. I may have a student, a professor, let me show this example. Supplier, and then I might have a customer class of organizations that hire us to do training. Now, this doesn't fit in a clean inheritance structure. There's no, without really stretching it, there's nothing I could do that would say that student and supplier are the subclass of the same thing. All right. But one thing there is in common for this, and in fact, there's something in common for all these. I might want to send an email. If the college has a mass emailing that they want to mail out information about a new program, for example, they might want to email all students, all professors, suppliers, and customers. It'd be nice, again, that we could create a little loop of all these things and put in the same loop, put in the same array list that gets looped through the student, the professor, the supplier, and the customer. Well, if they were defined as separate classes, we couldn't create a single array list that would hold them all, unless we create what is called an interface. I'm going to create an interface called emailable. And these don't inherit from it. They implement it. And an emailable, this interface is kind of like an abstract class, except it's not going to have any attributes, and it's only going to have abstract functions. So what are something that we would want to do to anyone that we can email? We want to get their email address. And we want to be able to send an email. So we could define an interface called emailable that has these two functions in it. Then anything that implements that interface has to have those two functions. Again, then we can create a loop that takes an array list of these things. We could add students, professors, suppliers, customers, whatever to that list, and loop through them and send an email to each of them. All right, I thought there was something else I was going to say, but I can't think of it. Oh, here's a feature that exists with interfaces that doesn't exist with inheritance. One class can only inherit from one superclass. Now, there might be a chain, like dog can inherit from mammal, mammal can inherit from pet. So in that case, dog inherits from mammal, that's the one inheritance. Mammal can inherit from pet, that's the second inheritance, or that's the first inheritance between mammal and pet. All right. With an interface, though, we could have many of these interfaces implemented. For example, we could create a billable interface. We bill our customers and we bill our students, for example. So calculate the bill. That might be defined in the billable interface. Now, the way you calculate the bill for a student is going to be totally different than the way you calculate it for a customer. But all we're interested in when we define the interface is what behaviors they have in common and what they need to implement. So let's look at the code example I have here for interfaces. Right. Here's my interface. Public interface, notice it doesn't say public class, emailable. And all it does is have one function in it. If you're emailable, all I can do is send email to you. All I need to know that you can do is have an email sent to you. So therefore, in these two classes, I need to send email here, and I need to send an email here. Now, the way the student sends an email is different than the way a supplier sends an email. That doesn't matter. As long as it has a function that matches this, everything is okay. So in the case of a student, your email address is a first name, a period, your last name, plus mail@lorainccc.edu. Then we send an email. I simulate it just by displaying a message, and we return some kind of status. Under supplier, there's an attribute for email address, and we send the email to that email address. Doesn't matter how it gets implemented, because both of these implement that interface. All we're making the promise of is having, in this and any other class that implements this interface, we're promising that we have a send email method. And notice what I do here. I have emailable s equals new student. I can do that. I can have the name of the interface. Anything that goes in there must implement that interface of emailable. Then I send email. Again, I could, in a more involved example, I could create an array list of emailable items, then loop through those and send those. Now, because I defined it as email, all I can do is send the email. I can't call any of these other student functions, which in this example, I don't have really any other ones. Gee, how do you call a directory has a space in it? I'm just going to rename it. can't change it. Let's duplicate this. Well, I know what I'll do. I'll drag that onto the desktop. Then I'll be able to go. All right, there we go. Okay, notice what I did and what the error message says. It says that public class implements emailable, but doesn't have the method send email because I put a little bug in here. I have send email with 2 L's. So now we can go make it match and it will compile cleanly. Bank. I had the wrong version open. And we send the email to the appropriate people. So the similarity between that is the assumption within interfaces that they're all abstract functions. The assumption with an abstract class, we can make some of them abstract methods and some of them not. But in either case, whether you implement a interface or inherit from an abstract class, you have to finish and supply the functions that are abstract. And again, it's assumed that all functions are abstract and emailable. So what about your assignment? What do you need to do for your assignment? You're going to create an interface for AC power device and have these 2 functions. ToString is a very common function, by the way. It returns a string that should be capitalized. This method returns a description of the device. So you could say for a light bulb, a 40-watt light bulb. Get kilowatt hours. And then here's the formula for how you calculate it. So in other words, create these classes. These classes will have different attributes, different methods, but they all need a get kilowatt hours and a ToString method. And your interface will have those 2. All right. That's all I have for today. We won't see you next week. I'm having cataract surgery next week, so there'll be a recorded lecture.